Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Jeremy, welcome back to the show.
Thanks for having me.
Well, the recent changes in the IRA bill are pushing a lot of projects forward very quickly at the moment. And as we're learning, there's a number of safe harbored blades sitting in yards and a rush to manufacture blades to get them up and meet the Treasury Department's criteria for being started, whatever that means at the moment. I think we're going to see a big question about the quality of the blades, and it seems to me that the cheapest time to quickly look at your blades before you start to hang them is while they're still on the ground, and to get some NDT experience out there to make sure that what you're hanging is appropriate. Are you starting to see that push quite yet?
No, not at the level we'd like to see it. As far as getting the inspections in, yeah, we have been seeing the push to get these blades out, but the few that we have been able to get our eyes on aren't looking good. The quality definitely down. We've just had a customer site come back with some findings that were surprising for a brand new blade that hasn't been up tower yet and in use. So it is much easier for us to get the technology and the personnel to a blade that's on the ground. It's cheaper, it's quicker. We can go through many more blades with inspections. Just access is just easier. Always comes down to access.
So that customer that you had there, like, what was their driver, right? Did they feel the pain at some point in time? Did they have suspicions of something not right? A new factory? Like, I don't know. Why is someone picking that over someone not? Because what like you said, overwhelmingly, the industry doesn't really do this. You know, even just getting visual inspections of blades on the ground before they get hung is tough sometimes, with construction schedules and all these different things, moving parts. So you had someone that actually said, hey, we want to NDT these blades. What was their driver behind that?
So we had done a previous round of inspections on some older turbines of theirs that were getting kind of long in the tooth, if you will. So they've had some experience. They saw what we could bring to the table as far as results and information and data on those blades. And it all turned out to be pretty reliable. So, we educated them on, if you have new blades coming in or even used blades coming in for replacement, that it's not a bad idea to get at least a sampling. And basically that's what they call us in to do. They had some brand new blades come in for some new turbines they're putting up, and they wanted a sampling. We did a sampling, and the sample showed that they have an issue with these brand new blades.
So, okay, so what happens then, right? Because I've been a part of some of these factory audits and stuff. And when you catch these things in the factory, you're like, hey, well, we got these 30 defects. And then the factory goes back against their forms, and they go, okay, material checklist is we'll fix 24 of them. The other 6 are on you, or whatever that may be. What happens when you find these things in the field at a construction site, right? Then does that kick off a battle between the new operator and that OEM, or what's the action there?
Yeah, so we've been on the OEM side and been through what you just explained multiple times and helped a bunch of the OEMs on that stuff. But unfortunately, when you're in the field and you find the same thing, it's a whole different ballgame. They typically, we won't see any of that. We won't be able to see what the OEM actually does unless we have information or channels that are a little bit different than normal to get that information. So, but yeah, so we'll give this information over to the customer. They'll go to their supplier, and then that'll turn into a dance, and where everybody's trying to pass the buck, basically, right? So, unfortunately, that's the way it's been. We'll see how this one turns out. It all depends on the relationship between that OEM and the customer and the end user.
So this is my last question about this, and then I want to, of course, jump topics. We have a lot to talk about here today. But the question being, okay, so say they do repairs. Is it then a good idea to bring you guys back in after those repairs are done to say, NDT, everything looks good here, basically clear to fly?
Yeah, so post-inspection on repairs is always a good idea. The aviation side, it's commonplace to post-inspect to repair. So yeah, definitely we'd want to come back. And that's something we're working on too in house, as working on a new training syllabus to where we can give some of the basic NDT tools to end users, so that if a repair company would come in, they would be able to have their technicians do a quick test. It's what we used to call like an operator level inspection. And then if they saw some of the stuff we trained them to, then we could come back and bring in a level 3 or a level 2 and look at their information, and then maybe do a reinspection if they thought they saw something that was bad.
Joel, you and I had discussed a couple of months ago with an operator in the United States in the Midwest that was going to be building or repowering a wind farm with turbines that were a couple of years old. Remember that discussion about what version of the blade are those? And it was an early version. I was surprised how long those blades had been sitting in the yard. And we said, well, it's going to have A, B, and C problem. You need to get somebody out there to inspect those blades before you hang them. That's the perfect case for NDT to get out there and look, because it wasn't like every blade had a serial defect. It was just kind of a random thing that was happening. Do you remember that situation?
Yeah, and it was really interesting too, because we're on that specific blade. We're on like version 9 of it out in the field right now. But since I think those were like in 2019, 2020, they had been safe harbored from. Those blades have the advantage of now having 3, 4, 5, 6 years of history within the market of all of the issues that pop up. So we were able to tell that operator, hey, since these things haven't flown yet, we know it's this, and this. You should have NDT come out here and do this. You should do this basically preemptive repair, this proactive measure before you fly these things. And I think what we see right now, Alan, like you said, just to open the episode with IRA bill changes and these new legislation coming out, there's a lot of stuff coming out of safe harbor that's going to get flown.
Oh, it's going to have a huge amount of blades that have been sitting there for a couple of years. But if you, the operator, haven't used those blades or don't know the service history of those blades, it's kind of a mystery. You better be calling other operators that are using them. But ultimately, when it gets down to it, before you hang those blades, and I know everybody's in a rush to hang blades, you better take a look at them with NDT, especially if there are known issues with those blades. And the problem is, you can't just do a walk down, which is what I think a lot of operators are doing right now. Send a technician down to make a look, make sure the blade's all in one piece. Like, I guess that's where they're at, or go walk inside and kick the tires and make sure all the bond lines are there. But it's a lot more complicated than that. And particularly if you know there's a source of problem on a particular blade, you can't see it. It could be buried deep inside. How are you going to know without having somebody with NDT experience?
To toss one more wrinkle into the whole storage thing. We had a project a few years back where the storage site, like, because the blades have been stored for like 15 years, like 7 years prior, the storage site was underwater for like 3 weeks, like 20 feet. Like, it was a massive flood, 20 feet of water or 10 feet of water, whatever it was. So it was a lot of water. Anyway, the bottom 2/3 of these blades were rotted because of water logs sitting in the water. And of course, over the last 7 years, they got cleaned up. They look good because of the rain and everything. They look bad. So we get out there, we're scanning laminates, and you get like halfway down the blade, and it just, with the terrible signal. And so we look back on the history, and sure enough, there was floods in the area. So those are things you got to look at too. These blades are coming out of these long-term storage. I mean, how were they stored? What weather has been through that storage area in the last whatever years? Because all that affects these blades when they're on the ground. I mean, they're fairly secure when they're up turbine. They're meant to be in that environment. They're not really meant to be getting just hit hard with weather when they're on the ground, because they're not sealed up. They're not, a lot of different things there.
Jeremy, it's a lot of times, even if the blades are in storage, they get moved around a good bit. And what we're finding talking to operators is that a lot of the damage you're seeing later on in some of these blades was most likely due to transportation. So maybe it was on the ship on the way over, or maybe when they got trucked to the storage site, or they got bumped into. It does seem to be a lot more of that. And the lift points seem to be another area where, I think there's some need to be taken a deeper look at. Obviously, the root bushings are a problem area for almost everybody at the moment, but also further out on the blade, there seems to be repeatable damage areas that you see that you wouldn't be able to detect until you got the blade spinning, and then you see these cracks develop. But a lot of that can be sussed out on the ground, especially with knowledgeable people.
Yeah, so that's just another reason for, pre-installation inspection. A lot of places you've got experts moving these things, experts lifting them, whatnot. But when they're on a ship or they're in a yard, a lot of times the guys that are professionals at moving them aren't there. So it's going to get moved by somebody, and they're not going to know exactly what they're doing, even if they're trying their best to make sure they're following procedure or whatnot. But you never know who's moving them or who's, what kind of skills or experience they have.
So that brings me into another question here, Jeremy, right? We're talking about skills and tools and these kind of things in the industry. When we say NDT, I would like everybody listening to know that when we say NDT, we're talking about a wide gamut of technologies, of solutions, of products, of methodologies for inspection here. NDT is just a broad scheme for non-destructive testing. We want to see inside of something without cutting it, breaking it, whatever we have to do. So can you walk us through the approach that kind of CIC will use? So, hey, customer comes to me, we have this issue. Okay, you guys have, I don't know, 20, 30, 40, 50 different ways of doing things. But how does that conversation usually start? What does that process look like for an operation?
So, it all depends on, it's case by case with what kind of issue they're looking for. But we recently had our lab open up in Ogden, Utah, where we've got a lot of in-house technologies now, like robotic CT, laser ultrasound, and then shortwave thermography, all the normal stuff we typically throw at these things. But composite focus, but we're able to do just about anything in a lot of advanced materials. And of course, a lot of that came from us servicing the DoD, the defense, and the aviation and space side of the house. But now that we have them all in one place, if a wind customer has, let's say they have a root issue, or they have a bond line issue, or they've got, or these carbon fiber main spars, you've got some new types of defects coming out of these. Typically what would happen was you'd cut into these things to see what's wrong. And of course, we've all seen what cutting composites does. It can be kind of messy and it can damage a defect that's existing. So you don't have a good look at it. But with these technologies we have in house now, especially the CT part of it, we can do a inspection. We can see everything of a area that is unmolested, right? So we can, let's say you find something in your scanning. Let's say you are an OEM and you're doing ultrasonic inspection or thermography, and you find something in house. Well, you can cut around that, send it to us. We can scan it and get a 3D image, of the full material thickness, and really break that down without having to damage the defect. And this is stuff that hasn't been really gone into on the wind side yet. We do it on aviation and space all the time for defect characterization. And then, we have a really good picture of what's going on there. We characterize defects that way, and we can also come up with better inspection solutions that way.
Well, that's interesting because I've seen it in aviation all the time. I assume they were doing it in wind, but you have to have a way to understand what the defects are. And when you see one, or especially if you don't understand what is causing it, you just can't cross-section that. You want to take a large section out and then scan it, understand what is likely the source of that problem. That's not being done in wind too much at the moment?
I think it is, but it's finally getting cheap enough that it's an option, right? So it's always been kind of expensive, but the equipment is coming down in cost. And we have a very unique system in house that's not typical to your normal CT system. So we use a robotic system, a cobot, so we can do very large parts, and composites, of course, are typically lower energy. So it's pretty much tailored for that type of part, where other CT systems might be tailored to other types of parts.
So then you can actually take some significantly large size pieces then? What's the biggest size part you can take and get some data out of?
Again, it comes down to the time and money. Right now, our largest piece is probably like a 10-foot by 6-foot section.
Whoa.
In theory, we could do a whole wing in theory, which could be a decent sized blade even, but that would require a specialized bay and some extra tooling. But right now in house, we do a fairly large sample.
Yeah, the first time I ran into you, Jeremy, in the wind industry was probably 3, 4 years ago, I think. And you may not even have known this, but it was on an RCA case for an insurance company, and they were like, we did our initial the team I was with at the time, our initial RFI. Hey, we need this data, this data, this data, and they sent us just library of stuff, and they were like, can you use this? What is this? And it was all NDT data from the issue that we were inspecting. I was like, this is the most amazing batch of data we have ever received on an RCA. Who are these people? Where did this come from? And I think that was my first, because from the oil and gas side, NDT, that's just regular. You're doing it all at offshore platforms. Like, you're always doing NDT. It's just an accepted thing. And, and of course, the offshore technicians for NDT, the rates are a lot different. And so I was like, okay, yeah, we're using NDT. This is when I first was really getting going in wind. I was like, oh, great, we're using NDT in wind. But since then, it's been, very specialized use, RCAs or like a special repair or something like that. You just don't see it very widespread. And it's frustrating because, from my past, like, you can see the value of this tool, and you see some tertiary kind of things out there where people are doing little NDT with robotics and this and that. But, like, it's like the industry hasn't grasped onto it. Like, I don't know if the engineers just don't know that it's available, or know the value of it, or why they're missing it. Because you go back to the idea of, you go to your general practitioner, the doctor, and say, like, okay, yeah, you got your knee hurts. Okay, yeah, shake it around a little bit. Like, okay, we need to probably maybe do surgery here. And before we do that, let's go get an X-ray or a MRI, so we know exactly what we're supposed to do when we get in there. We make it efficient, we make bang, 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 clean cut and all, and we're done. That's the same thing as, like, to me, a really deep lightning repair. You know what I mean? We hear these war stories all the time of people saying, like, oh, yeah, they quoted us $20,000, and this team quoted us $50,000, and then the $20,000 team, we gave the project to them, they got in there and it ended up being $100,000. Well, if you would have spent 15 grand or 10 grand or 5 grand or whatever it may be to get some NDT work done on this thing before you opened it all up, you might know what you were getting into and be more efficient, come with the right kit, less standby time, the right technicians on the job, all this stuff, just like your surgery on your knee. I mean, have you seen anybody picking up that idea in the wind industry?
Not as much as I'd like. There's some of the OEMs that have tried to automate, tried to bring it in. Most of them do some inspection, and it really is plant by plant, depending on what kind of support they have. As we all know, whenever times are tight, or you need to have the cycle time as the most important thing, quality is the first one to get cut. So, that makes it a tough sell in a lot of people's books, because we add cycle time and we add cost at the manufacturer. But the other thing I've seen is, when they do try and implement something where, let's say, some automation where they can do this stuff quickly, and, over the mass produced parts that they have, they go to an automation company that doesn't know much about NDT. If they do know about NDT, it's not wind NDT. So, they would be better off if they would contact a company like ours, or there's a few of us out there where a majority of our work is in the wind industry. There's a couple in Europe, there's a couple over here. Get those guys in first. It doesn't have to be us, but get somebody with practical, experience, and that practical part is the most important part. And have them help you with a practical approach to the inspection with automation. I mean, there's simple and easy ways to do this that just haven't been done yet. Not going to say it's going to be cheap, but it should be usable. It's not going to end up on a shelf. Like I always keep telling everybody, all these systems I've seen millions of dollars spent, and it just sits on a shelf collecting dust. Happens all the time. And that's in the field as well. We see a lot of really cool robotics things coming out, a lot of drone, interior drone stuff, exterior drone stuff, and just looking for a practical approach. These guys, a lot of them come at it with really good intentions, but they don't have the experience needed to know what they're going to run into when they do these types of applications, and therefore kind of miss the mark.
Jeremy, I've been to a site recently and noticed up on the whiteboard blade bolts were their particular issue, and I saw a couple of the blade bolts sitting in the shop there, and they had cracks, big cracks, and broken blade bolts. I thought, man, that's a huge problem. And the number of turbines that were listed was incredible. I just thought technicians and mechanics are out there all day fixing these blade bolts because there's so many bolts per blade. You just multiply the numbers. Like, wow, they have a huge problem. But the issue is you can't really tell which blade bolt has a crack in it while it's installed unless it falls out, and they were having that problem too. How can you attack that problem from an NDT standpoint? Can you suss out what bolts are likely to fail or in the process of failing?
Yeah, so bolt inspection isn't new. Sounds kind of new to the wind industry, but oil and gas, aviation, we've been doing bolt inspection on those for quite a long time. So even on marine with sailing vessels with the mast bolts. These are things that we can do ultrasonically. When they're installed, and look for cracks at different lengths. Of course, we need a little bit of information about the bolt itself, the material, design, length, all that stuff. But no, we can definitely do a inspection, whether it's installed or not installed on the bolts. It wouldn't even be a bad idea to get the bolts inspected before they get used for installation. That can be done with a few different methods that are pretty quick. But the other thing we're working on actively is a monitoring system also, where we'll be able to attach the sensors to the end of the bolts, and it'll be able to monitor the health of the individual bolts over time.
Can you see inclusions, or what is the defect that's causing these bolts to start to crack? Is it something in the casting of the bolts themselves, or in the machining? Are they overheating them when they're getting machined, or not tempering them correctly?
All of the above. So we can definitely see that. On new bolts, you'll be able to see if there's manufacturing defects or if there's material defects that maybe didn't get caught during manufacturing or receiving inspection.
I have one of these bolts that's like 2.5 feet long. You can actually see inside and tell me where that defect lies, because you cannot see it on the outside when they're all finished.
Right. Typically, we use ultrasound for a quick inspection on that. If it's out of the turbine, first year's X-ray and mag particle, that kind of trend. Everything you get your tops out of. But UT seems to be pretty straightforward on those. We can even find the cracks that are in the threads if we have the right pitch angle to the beam. Okay,
so if you just received a whole truckload of these bolts, which is sort of the quantity they're coming in right now, you could UT inspect each one of those before you took them up tower and spent all the money to install them, and make sure that the manufacturer actually is delivering a proper product.
Correct.
Are they doing that at the factory? Why are they not doing that at the factory?
Because they're told they're good when they get them from the supplier.
That seems like a huge, if I'm the attorney at Blade Bolt Company China Limited, I would want to make sure that I wasn't going to kill somebody, because those things are falling out and they're just going to lawn dart it underneath the turbine.
And a hard hat's not going to save you from a bolt coming down.
Well, you could tell by the number of problems that they were having that they had replaced some of these bolts, and the new bolts had also had problems. So as a sequence of replacements, at some point you have to stop that process. You have to validate the part you're putting in the turbine is correct, right? When you have to do that.
And on my side, you get what you pay for, and if you're going to go for cheap, you should probably spend a little bit to make sure what you're getting is somewhat decent.
So what would that entail to check them in the O&M building? And say you got 100 bolts show up on site. What are we talking about in terms of time to make sure that at least the sanity check is being done before you spend the money to install these bolts?
If we put together something, it can be done in a few minutes per bolt.
Throw me a time and a dollar amount. Are we talking about millions of dollars or thousands of dollars for this?
Thousands of dollars, probably. We could probably get a system together that would be extremely cheap and effective. So, if that's something that needs to exist in the industry, then we can definitely put together something that we can sell.
Let me ask you about the thing I've seen, the sort of the unscientific blade bolt check, where have you seen this, Jeremy, where they hang the bolt at one end and they tap it in the other, and it rings, right? It makes this kind of a bell noise. And they think they can hear if there's a defect inside of there. Can you hear if there's an inclusion or some sort of crystalline defect inside this blade bolt by tapping it?
It's a resonance test, and I think you could definitely tell. You can definitely tell if there's something going on. I think you would have to have a good control though. So if you have to have one good bolt, right, to balance against, I would imagine.
And someone with good hearing.
Yeah, it's tap testing with anything is always subject to so many things. So it's better than nothing probably, but
You see the little tap hammers. I've been on site and seen the little tap hammers sitting on guys' desks that are the calibrated tap test tool to see for DLAMs. That is not an easy tool to use, and it's not even right for all the applications because it'll see something on the surface, but what can't it see?
so there is a regulated way to do tap tests. It's you have a certified tap test. You have to have noise levels in the environment have to be below a certain amount. The person doing the test has to have a hearing check annually, and it has to be at a certain level. The tap hammer is proportional to the thickness of material you're looking at, because if you're looking at it's only good for so thick. Like if you're looking at 10 millimeters, 15 millimeters, fine. But once you get past 20, you're going to use a heavy hammer. And I've seen hammers in some plants that were probably causing damage, because they were so heavy. It was a piece of rebar with a ball bearing welded on the end of it, and they're just hammering away. And it was so loud in the bay that even when they got lucky when it crossed the dry glass area, they didn't hear it. It just kept on rolling.
I want to expand the scope just for a minute. There's going to be a lot of sites right now because of the changes in the IRA bill that are not going to be able to get their next round of production tax credits and reapply because they're going to miss this window, right? So you have blades that are 7 and 8 years old, or turbines 7 and 8 years old. You're not going to be in that window of opportunity pretty much, depending on what happens with the Treasury rules. That seems like it's going to force operators into taking a deeper look at the health status of their turbines, maybe more than they have in the past, to know, am I good for another 10 years? Or if I do a little bit of preemptive maintenance on my existing fleet, well, can I get them 10 years, maybe 15 years? That's the look I think that everybody's trying to evaluate right now. And I think the key to all of that is to actually have some NDT data, to actually look inside and to see, do I have a blade root issue that's still early, that it's going to pop up at year 12? Do I have a cracking issue that I need to go take a look at? How does that factor into the planning over the next year, 18 months?
For me, it was a little eye-opening when we went down and visited our friends down in Australia. And that's kind of how they live, right? With their wind farms. They have to make them last. And it was eye-opening. And I just had a conversation with one last week, one of the people we met down there, and they were looking into main bearings, a pitch bearing, and they're cracking, right? So these are things that can be inspected with ultrasound or other things, and we can find these cracks internally. Like this is stuff that we don't get to see much in the US or markets like ours, because they get replaced, right? Everything gets we have a throwaway attitude when it comes to blades because of, repowering and other things. Where, places like Australia or like in the islands where we've got a customer, that's not how they look at it. These things have to last 30 years, or longer, so inspection and preventive maintenance is the way to go. I mean, again, oil and gas, the stuff they have has to last a long damn time. A lot of, they do preventive maintenance, they have repair schedules or replacement schedules, all this stuff. And maybe we got to start looking at stuff a little more smartly on our side, and budget for more inspection on these things that we know will go bad over time. And it's not necessarily just the blade, but other parts of the turbine as well. We've got a yaw bearing we're looking at too, and that's a pretty large part to have a crack in it. But
Yaw bearing.
Yeah. So these are things that can crack. So we're looking at with different inspection methods as well. So
do you think the roles are reversing, that the Australian, European methodology to keep turbines up and running is going to be applied to the States? And how is that going to transfer, that knowledge transfer going to work? Because the staffs and a lot of U.S. operators are set up for that 10-year period. Like they don't really think about year 11 anymore. They haven't for a number of years. How do they get spooled up on that, and what resources are they going to need to get to year 15 and 20?
If I was them, I would be reaching out to our partners in Australia or Europe and ask those questions. And a lot of these large energy companies are not just U.S. They're multiple, areas of the world that they run in. So they should have the knowledge and the leverage in house. They're just gonna have to connect those people.
Well, yeah, that's going to be the key for the next couple of years, just because a lot of the engineers and staff in the United States have not been to a lot of conferences and talked to technical people because they haven't needed to. It's more of, hey, I need to keep the blades running a couple more months, and then we're going to move on to the next project. We got a repowering project going on. It's been in that sort of build mode for a number of years, and that whole logistics internal workflow is going to change, where they need to be bringing outside resources in to help them understand what they're missing. What key components do they have over in Denmark or Germany or France that we don't have on staff at the minute, and why do they have it? One of those is going to be NDT, and a lot of it, I think, just because of the age of the turbines and I would say the era in which they were built. It's going to lead themselves into more inspection. That's, I think, an avenue for CICNDT to explore, obviously. But I think the key is to get the engineers and the sort of the maintenance staff out into the world again, and to come to some of these conferences. Like when Jeremy speaks, you should be there listening, because he's going to give you all the answers in about 30 minutes of what you need to go do. That's the key, right?
Right. And I mean, not just myself, but anybody in a position where you've got knowledge and experience that would benefit the whole industry. Start volunteering, get out there and pass the word out. It's like, we had this thing in the NDT industry where, a certain generation, the older guys that had all this experience, all our senior level 3s, back then it was, you wanted to hold everything in because that was your key. That was your ticket to getting a payday. Right. What ends up is when those people all retired or worse, then all that knowledge got passed down, and it was all kept up. And you look at the aviation industry, the fumbles they've had lately with quality, and that's because of that, because they don't talk to each other. None of that. This year, all these problems they're having right now in aviation, stuff that they took care of in the 50s, right? And they just forgot. So now we have a chance to try and not do that in the wind industry. If you're an expert in something, get out there. And I mean, it's tough. Like, I don't like talking in front of big crowds or anything, but it's once you get rolling and people get engaged, and with guys like you to help out, it's not a bad time.
Just set the ball on the tee and let you take a whack at it.
But you could be the difference between somebody having a whole farm, a wind farm go down, or they have them like that. We've come across people that have had blades or turbines offline for weeks, if not months, because they have an issue they don't know if they can do anything about. And then they bring us in and like, hey, we did this inspection, this is repairable, or we did this inspection, you should just get rid of this blade, or whatever. It's just they've been paralyzed, and I don't think that's something that needs to happen either.
Well, they shouldn't be paralyzed. They should be calling CICNDT or going to the website, CICNDT.com. Get a hold of Jeremy, get a hold of the staff, because they have a tremendous amount of knowledge about blades, about how to inspect them, and how to keep the turbines running quickly. Yes, it costs a little bit of money, but it's well worth it when you have these turbines down for months on end. And I've seen that this year. It's insane. They should have called CICNDT and gotten their turbines back up and running. Jeremy, how can people reach you directly? Can they get a hold of you on LinkedIn?
Yeah, get on LinkedIn and just search Jeremy Heinks, or you can go to our website, CICNDT.com, and we've got links to get a hold of us there.
And go to some of the wind conferences, because Jeremy's going to be there laying down the knowledge on NDT, and you won't want to miss it. So, Jeremy, thank you so much for being on the podcast. We love having you.
Thanks for having me.